Welcome to this short introduction to the new AnyBody modeling system version 6.0. I'm Michael Damsgaard, Head of Development here at AnyBody Technology. In the following, I will briefly introduce you to some of the new features in AnyBody 6.0, both user interface and simulation core, and to the news in the AnyBody Managed Model Repository version 1.6, which is released at the same time and as part of AnyBody 6.0. Here is a short overview of the most important news in AnyBody 6.0. The simulation core is updated quite a bit. The kinematic engine handling all motion analysis is updated significantly, and in particular the muscle wrapping facilities are extended. We will get back to these updates shortly. But in addition, the core has been updated with new versions of all computational third-party modules, and finally a full 64-bit version of the AnyBody modeling system is available. All these core updates has individually contributed to improving the computational efficiency, so you can get quite substantially reduced calculation times depending on your model and your computer. Typically we have seen 10 to 15% reduction of simulation times with typically AMMR-based models. The AnyBody modeling system's user interface features new visualization options, model navigation options, graph options, and finally some nice extensions to the getting started documentations in the tutorials. AnyBody Managed Model Repository 1.6 features new template models, a new and simple script interface to the human model, and several updates to the various body parts. I'll give you much more details on this later. For more details, please also refer to the release notes, which you will find under the Start menu after installing AnyBody 6.0. Let us start with muscle wrapping. The muscle wrapping algorithm has been updated almost entirely. It is now based on a new contact algorithm that provides much larger flexibility and in most cases superior computational speed. For single-line muscles, it still solves the same contact problem and will with some numerical tolerance give the same result as the old method. In addition, new options for setting initial positions of the muscles before it is wrapping and for handling last posture steps using posture-dependent initial positions has been added. These two features provide significantly improved robustness and can allow your models to run with much larger time steps than before. The new algorithm's flexibility has been used to enter an entirely new muscle wrapping feature, where several lines are connected laterally. We hereby allow you to better model sheet-like muscle geometries. To the right you see an example of such a sheet-like muscle, the deltoid. The deltoid is one of the very demanding muscles to represent reasonably with single-line shortest path wrapping. It is typically assumed to wrap over a sphere, and over a large range of motion this typically gives serious problems due to jumps in the shortest path solution. Connectivity between the branches of deltoid are needed. The new method treats all branches of deltoid as a hyperelastic sheet. By controlling, for instance, the outer branches properly over a full range of motion, it is easy to model all the inner branches in a reasonable manner. The new sheet wrapping feature provides such a hyperelastic sheet modeling. Each branch of the muscle is wrapping over analytical surfaces, just like in the shortest path muscle, and there are several additional options for adding constraints over the shape of the sheet. I have to mention that the model to the left or to the right is a prototype and it's not yet available in AMMR. If you're particularly interested in this model, please contact us directly. I can briefly show you the model over a large range of motion. Let us have a look at the more general changes of the Kinematics engine. The updating scheme during the kinematic analysis has been rearranged. This has implied new data which can be reused better, thereby saving time. But more important for you, some of this data has also become available in the model. For all kinematic measures and derived objects like kinematic constraints, joint forces, a new folder called RefFrame output contains the output associated with each reference frame. For the kinematic measures, it's only what we call the so-called kinematic Jacobians, but for forces it's more interesting because it contains 3D forces and moment vectors. These 3D force and moment vectors are unique and the same for all force objects and thereby easy to compare. You remember that previously you could only find the force representations called Fin and Fout, and these were associated with the kinematic measures by the principle of virtual work. This is a sound and good mechanical principle that is good for modeling, but it can be difficult to comprehend. And therefore we had force moment measure objects that could remeasure these forces into 3D forces and components. All this still exists in the system, of course, but now the 3D forces and moments are available in the standard output and thereby much easier to access. The 3D force and moment vectors now available in the model data can also be visualized in model view. The vectors are directly used for standard force drawing. Just like many other objects in the model, the standard or the auto-generated view of forces can be turned on, for instance by a few clicks in the model tree. This is shown in the screenshot to your right. The video to your left shows the result of the operation in the right-hand screenshot. All forces for all muscles in the leg are turned on by a few clicks. You can show current values of forces, or you can also show individual components. This means that you, for instance, can show the force components of a joint or another type of constraint. And of course the 3D force and moment vectors can also be plotted in AnyBody's chart view and exported to files. Regarding AnyBody's chart views, I should mention that AnyBody now only has one chart view. Previously AnyBody had two chart views, one the ChartFX, which was based on a third-party plugin, and one which was based on AnyBody's own AnyChart component. The AnyChart is special in the way that it's available inside the model script as well as in the user interface. Therefore it can be placed inside models like you see here in the lower picture. In AnyBody 6.0, AnyChart has been updated significantly, so it has a better user interface with an extended toolbar for accessing style options. Therefore the ChartFX component has finally been retired. In particular, I would also like to emphasize the Python interface. This gives you rich options for exporting your charts and continue styling it before publication using Python scripting. Regarding the output of forces, the find element interface should also be mentioned. As you may know, AnyBody has a dedicated converters to abacus and answers. They convert a standard export output format from AnyBody into code for these two FE softwares. But standard exported format could also be used to prepare your own interface to any FE solver. Anyway, the standard export format has generally been prepared for export to a single FE bone model, that is, from a single segment of AnyBody. However, some FE models cover multiple segments, like the example to your right made by Gadomski et al. When exporting to this model, you want to export the forces from AnyBody that represents the elements which are not in the FE model. Here disk forces are already a part of the FE model, and therefore the AnyBody disk joints are not relevant to export. Therefore the FE export function in AnyBody has been equipped with include and exclude filters, so you can easily specify in the script which objects you want in and out of the export. Before, such filtering was typically a manual process done in the FE software after transferring. This is of course very inconvenient when processing many forces from many files of many AnyBody models of daily activities. And therefore scripted filtering in AnyBody is a very practical feature and a strong support for multi-segment FE modeling. In the beginning, I also mentioned new model navigation options. I'll not go into details with this, but just notice that we have decided to extend the toolbar of the AnyScript editor. It now contains new buttons that take you either to the model tree or to the file tree. For a more thorough description of the model navigation, please see the tutorials or the new YouTube demonstrations. I will now turn to the news in the AnyBody Managed Model Repository version 1.6. First, a few remarks on the body parts. The arm model has been updated using the new muzzle wrapping features. This has improved robustness of the arm model. And some of the muzzles has improved wrapping geometries, providing better moment arms. The LegTD model has been renamed to LegTLEM in acknowledgement of the founding dataset called TLEM. This is short for Twente Lower Extremity Model. The model contains several updated scaling definitions based on uniquely defined anatomical frames. This is in preparation for a new dataset being developed in the TLEM Safe project. Please refer to a special webcast on this project by Professor Nico Fadonchov, who is leading the project. And finally, the new foot model developed in the A Footprint project must be mentioned. This is a multi-segment foot model that, for instance, takes in pressure mat data measurements. The model is developed in collaboration between AnyBody Technology, Glasgow University and Maastricht University. Very important news regarding the model repository is a new and easy human model setup. The human model has been wrapped into an interface which provides a full functional human model with one or few lines of AnyScript code. This provides the default full-body human model. Before inclusion of the human model, optional definitions can control the actual human model in your setup. These options cover all or at least all the relevant of the options that you have been used to in the previous versions of AMMR. Now it is just simpler and better documented. A new tutorial provides much more details on these options, but I should give you a few hints here. Simple body configuration such as enabling body part, muscle types is done with simple statements. Selection of standard AMMR scaling laws is enabled by simple statements. And even entering your own customized scaling laws can be done with a simple statement referring to the scaling law in your own directory. Custom scaling options for individual segments can be added as extension to your selected standard scaling. Here humerus is serous elongated to show the concept. Much more information on scaling can be found in tutorial and previous webcasts. I should also remind you that patient-specific or subject-specific morphing fits into the concept, just like you are used to from previous versions. Another important addition to the human model interface is a set of default drivers. This is a set of joint angle drivers plus pelvic positioning that provides a full poster definition of the human model. This is in fact the so-called mannequin drivers previously existing in some demo models. As you can see in the model tree, these drivers are now placed inside the human model. And a model with and one without these drivers exists too. These default drivers can be used as normal hard kinematic constraints, or they can be used as soft constraints that can be compromised. As soft constraints, they provide or they function as a kind of preferred angles. This is very convenient during development of models with new kinematics drivers while you are playing around with such a model, or as a simple form of posture prediction. The model to the right is an example of such simple posture prediction. The soft default drivers provide the preferred angles, but the hard drivers specify the hand position. Here the hand position is attached to a model view widget, which is dragged to new positions by the users. Notice how the arm and even the upper body moves when the hand position is dragged to new position. Let's have a quick look at the application models. In the beta section we have two new models, an application of the new foot model and a model of the hind limb of a rat provided by Ulm University in Germany. In the example section, all models have been updated to follow the new implementation guidelines, and most models are also updated using the new human model interface, which was just described. A few of the models here are marked as new, but they are basically renamed and fusions of previous models which were very much alike. Features in previous bike, gait and standing models can therefore be found as options inside these fusioned models. Finally, a new model section called templates are introduced. These models provide a good starting point for developing your own applications. They can be grabbed from here and copied to your own application model library. To help you with this copying, a new template wizard has been added to the AnyBody GUI. The template wizard is started from the new main file button. You can select any template model in the AMMR template sections from this wizard. The wizard will copy the template model to your location and rename it to your choice of target name. It will also ensure that your choice of target folder contains the proper library definition, that is a libdiff.any file. If it doesn't exist, it will create one that is suitable. The wizard will also handle your own templates if you put them in the template folder. It is however recommended that you make your own templates outside the AnyBody installation files and choose to use My Templates in the top selection menu when you want to use your own customized templates. Finally, a remark on the new documentation. The new AnyBody tutorials contains no less than 4 getting started tutorials. They are all changed to follow the new modeling interfaces and recommended model structure. In particular, 2 of these tutorials are new. One of them is devoted to the AnyBody Managed Model repository. This one will cover all the model options of the human model as described previously, and it also has a section about the typically and recommended structure of a model. This introduces concepts like the library definitions and well-defined in- and output directories. The other new tutorial is about creating application models using the new concepts mentioned in this presentation. I would recommend that even experienced users have a look at these tutorials to get a deeper introduction to many of the things that I have just mentioned here. And once again, I would like to refer you to the YouTube demonstration videos that we have started to publish. Before I close this presentation, a couple of final remarks. The new AMMR models do generally not run in older versions of the AnyBody modeling system, so we strongly encourage you to update as soon as possible. Old models may need updates. Generally, we try to warn you about such updates when loading an old model in AnyBody 6.0. We try to ensure that the needed updates do not prohibit you from still using the models in older versions. This way we try to make your transition to the new version as smooth as possible. With paid maintenance, you are entitled to run the AnyBody 6.0 with your current license, and your current license file should be working, but you must import this license file again with AnyBody from the AnyBody 6.0. With these final remarks, I would like to thank you for your attention. I just have one more slide with some useful information, and I will leave this on for a little while.